David Ken here with another question from your Hayes and Harris Math SL textbook. We're looking at Chapter 9D, Question 5, and this is about applications of sine rule and cosine rule. In this question, we're told about hikers Ritva and Esko. They leave point P at the same time. Ritva walks 4 kilometers along this bearing, 40 degrees, and then walks another 6 kilometers at a bearing of 155 degrees. Esko instead walks directly from P to the campsite. So we'll draw in his path now. The first question, AI, asks us how far does Esko hike, so we want to know the length of this line. There's a number of ways to go about solving this, but since this is about sine rule and cosine rule, we'll try and use those rules. What we'd like to know is we'd like to know this unknown side, and we already know 2 sides. So this sounds to me like Pythagorean theorem for non-right angle triangles, or cosine rule. Cosine rule says c squared is equal to a squared plus b squared minus 2ab cosine of the angle c between them. So if we want this unknown side, that'll be c. These two will be sides a and b, and it doesn't matter which. The only thing that we're missing is this little angle here in between. To get that angle, we're going to have to look at the angles that we already know, and those are the angles for the bearings 40 degrees and 55 degrees. The way that I'll find it is by splitting the angle up into 2 pieces separated by a vertical line. And the reason that helps me is because, 1, it gives me the z rule on this side. We have 40 degrees, and that'll have to be 40 degrees here. Then on the other side, we have this little angle, which together with 155 degrees must be 180 degrees. So 180 take away 155 must be equal to 25 degrees. And so that little angle in there must be 25 degrees, and so altogether the whole angle would be 40 plus 25 degrees, or 65 degrees, and that would be the angle opposite our side C. So we can now solve for side C by plugging in. C squared is going to be A, that's 4 kilometers, plus B is 6 kilometers. And remember, it doesn't matter which is which. Those 2 sides are equivalent. Take away 2 times 4 times 6 times the cosine of 65 degrees. 65 degrees is not a major angle that we need to have memorized, so we're not going to be able to do this in our head. We have to do this with a calculator. We'll plug it all into a calculator, making sure that we're in degree mode, and what we'll find is that c squared is equal to 31.7 to 3 significant figures, or c is equal to 5.63 to 3 significant figures. Whenever you take a square root, you need to remember plus or minus, but since we're talking about distances, we can immediately throw away the negative solution and say that the distance is positive 5.63 kilometers. Okay, for part 2, the question asks us, in which direction does Esko hike? So what we have to find now is we have to find the bearing from north to C. Now, to find that bearing, we have a number of options. What we'll need to do is we'll need to find this angle in the triangle, because the blue angle P plus 40 degrees gives us our bearing. So what we want is we want an angle in a triangle. We could use cosine rule again, because we now know side C is 5.63 kilometers. So we could use that side and that side and that side to get this angle. We could also use sine rule. I'll choose to use sine rule here to find an angle. Sine rule in general says that the sine of the angle that we're looking for divided by the opposite side to it, that'd be 6 kilometers. So we want that blue angle P, and the side opposite to it is 6 kilometers, is equal to the sine of another angle, and we know this angle, 65 degrees, divided by the length of the side opposite to it, which is 5.63 kilometers. We'll have to rearrange this to solve for the sine of angle P, and we'll get that the sine of angle P is equal to 6 by multiplying 6 to the other side times the sine of 65 degrees divided by 5.63. Now to solve for the sine of angle P, what we're going to have to do is plug this into our calculator. Now 65 degrees, again, is not a major angle on the unit circle, so we'll have to use the calculator, and we'll have to make sure we're in degree mode. When we plug that into our calculator, we find that the sine of angle P is equal to 0.966. We'll take the inverse sine, inverse trigonometric function, and our calculator in degree mode tells us that the result for P is 75.0 degrees to 3 significant figures. Once again, whenever we use an inverse trigonometric function, what we have to do is check the unit circle to look for other solutions, because the calculator is only going to ever give us one solution, and it's not going to warn us when there are other possible solutions. So we'll take a look. We want the sine of the vertical component 9.66, which is almost all the way up to 1. Now we already know one of the solutions, an angle which has this vertical component. The calculator told us it was 75 degrees. But there are others. There's this one, which would be 180 minus 75 degrees, and that'd be 105 degrees. So what we have to do is we have to determine, of these two solutions, which of them are possible. Well, looking at the triangle that exists right now, what we see is that one of the known angles is already 65 degrees, which means that if this angle P were 105 degrees, then the sum of the two angles would be 105 plus 65. That's 180 degrees. Now for a triangle, the sum of the three angles should be 180 degrees. So if the two together already equal 180, then there's no room left for the third, and we're not dealing with a triangle like we intended. And so 105 degrees cannot be a solution. In addition, we need to think about rotating around the unit circle by 360 degrees, but clearly if we go 75 plus 360, that takes us well beyond the 180 degrees, and so 75 is the only possible solution for angle P. Now the next thing is we need to turn that into a bearing, because we want to know the direction that Esco hiked in. And so the bearing from angle P would be angle P plus the initial 40 degrees. So 40 degrees plus 75 degrees. So Esco hikes at a bearing of 40 degrees plus 75 degrees for a total of 115 degrees to 3 significant figures. Let's take a look at part B. Part B says that Ritva hikes at 10 kilometers per hour and Esco hikes at 6 kilometers per hour. Knowing that information, we want to know who arrives at campsite first. To answer this question, we need to know how speed, distance, and velocity are related. So for part B1, we need to remember that velocity is equal to displacement, or distance, divided by time. And so if we want to know the time that something takes, we'll rearrange this equation by multiplying across by t and dividing across by v to get that time taken is distance divided by velocity. So, for Ritva, the time that Ritva takes to hike would be the distance that Ritva travels divided by Ritva's velocity. The distance that Ritva travels is the combination of two segments. She goes 4 kilometers this way, and then 6 kilometers that way, for a total of 10 kilometers. So she travels 4 plus 6 kilometers, and the question says that she travels at a velocity of 10 kilometers per second. This gives us 10 divided by 10, or 1 hour. Then we have the time for Esco. The time for Esco is the distance that Esco travels, divided by the velocity with which Esco travels. Going back to the diagram, we already determined that Esco travels a distance of 5.63 kilometers. Meanwhile, the question tells us that his velocity is 6 kilometers per hour. This gives us a total time of 0.952 hours to 3 significant figures. So who arrives first? Esco arrives first because it takes him less time to arrive at the point. For part 2, it asks, how long does ESCO have to wait for Ritva to arrive? So what we want is the difference in times. So that would be Ritva's 1 hour, take away ESCO's 0.952 hours, leaving us with a difference of 0.048 hours. So ESCO would have to wait 0.048 hours for Ritva to arrive. That's a funny way of expressing it. I'd rather express it in minutes. So what I'm going to do is I'm going to multiply the number of hours by 60 minutes per hour. As a result, hours multiplied by per hour cancel, and we get a total of 2.9 minutes. So basically, ESCO doesn't have to wait very long at all. Finally, we'll look at Part C. Part C asks, on what bearing should they walk from the campsite to return to P? So they're at the campsite and they want to go to P. So from here, what is the bearing that way? To solve this, we'll put in our axes. And to get the bearing, there's two ways to do this. We can get the bearing all the way around this way, and that would be the positive bearing. Or we could get the bearing in the negative direction. And the bearing in the negative direction is going to be quite a bit easier because the bearing in the negative direction has a Z rule with the bearing that ESCO hiked. So this angle, we'll call it angle B, and this angle must be the same, and angle B plus the bearing that ESCO hiked must be 180 degrees. So the bearing for part C would be 180 degrees, take away the bearing that ESCO hiked, which was 115 degrees, and we'll find that the bearing that they have to hike to return would be 65 degrees, but that's just the value of the angle. That's 65 degrees, that's 65 degrees, but since this is a bearing and in the negative direction, it's going to be a negative 65 degrees. That's one way to express it. Another way to express it would be as a positive bearing, and the way that we can do that is just add 365 degrees to the bearing. So the bearing could also be negative 65 degrees plus 360 degrees, and that'll give us a total of 295 degrees.